A new tech company looks to drastically reduce electrolyzer production costs in ways that should make my old supply chain professor really excited. And an aviation collaboration in the UK is looking to lay the groundwork for government regulation and policy, and it will have global implications. I'll go over all of this and give my thoughts on today's Hydrogen Podcast.
So the big questions in the energy industry today are: how is hydrogen the primary driving force behind the evolution of energy? Where is capital being deployed for hydrogen projects globally? And where are the best investment opportunities for early adopters who recognize the importance of hydrogen? I will address the critical issues and give you the information you need to deploy capital. Those are the questions that will unlock the potential of hydrogen, and this podcast will give you the answers. My name is Paul Rodden, and welcome to the Hydrogen Podcast.
In an article in TechCrunch.com, Tim Dechant writes, Evolo bets hydrogen won't happen without better manufacturing. Tim writes, the path to starting a business is sometimes obvious, even if the founder doesn't always realize it. That's certainly true for Jimmy Rojas, who took the first steps towards founding his startup Evolo 3 years earlier as a graduate student at Stanford working on hydrogen and energy systems. It continued when he worked at Baruch Future Ventures analyzing potential deals. He says, I was looking for the hydrogen deals. He says, I remember those guys joking that I was a terrible investor because I passed on every single deal because I found issues with every single company out there. By the end, we were like, it's better if I just start my own. Hydrogen is already a key ingredient for many chemical manufacturers, and startups and investors alike are betting it can help eliminate carbon pollution from everything from steel and cement to aviation and long-haul trucking. Thanks to his experience, Rojas felt he had a good sense for where hydrogen's problems resided. To him, the biggest was in manufacturing the electrolyzers that make hydrogen gas. He says, electrolyzers are very expensive. They are really hard to produce, logistically complicated, very hard to transport and install, and they are often entangled in politically and environmentally problematic supply chains. Rojas' company, Evolo, is attempting to solve all of those at once by focusing not on novel materials, as is often the case with hydrogen startups, but on manufacturing. In the process, he hopes to make hydrogen a key part of the world's energy systems. He says clean, cheap hydrogen could be a platform on which completely new industries can be developed in the future. Many companies spend a lot of time creating a specialized membrane, one of the key components that allows hydrogen to be separated from water. But if hydrogen becomes a sufficiently large market, Rojas suspects that electrolyzers will quickly be commoditized. Even today, membrane development has become a bit of an arms race, saying someone will always have a better one. Evolo does make electrolyzers of its own design based on alkaline electrolysis. In an alkaline electrolyzer, two electrodes are submerged in a solution of alkaline water, usually consisting of a high concentration of potassium or sodium hydroxide. As electricity flows through the alkaline water, it splits water on one side into hydrogen gas and hydroxide and merges hydroxides on the other into water and oxygen. Alkaline electrolysis differs from the other main approach, proton exchange membrane electrolysis, in a few ways. One of the most important, though, is that alkaline electrolysis doesn't require expensive exotic metals like platinum. That gives alkaline electrolyzers a cost advantage from the start, one that Evolo says it builds on with its lower cost manufacturing. Evolo also designed its electrolyzer stack, the core of the system, around inexpensive, domestically sourced materials and components. Rojas says, we went to the power supply companies and we asked them for the cheapest, most readily available power supply that they had. We did it with every other component, the pumps, the heat exchangers, every single thing. To further trim manufacturing costs, Evolo uses roll-to-roll printing, a technique pioneered centuries ago by printing presses and more recently used in battery manufacturing. Both electrodes and membranes, the two components of an electrolyzer, can be made using roll-to-roll equipment. As they come off the line, they're cut to size and assembled into the final product. The result is a compact and efficient electrolyzer that will be easy to transport and install. The goal, Rojas said, is to, quote, be prepared for this scenario in which electrolyzer stacks can become a hardware commodity. Evolo is still working out the kinks in its manufacturing process, though Rojas expects that the company's first factory will be up and running by the end of next year. When it's at full capacity, it will be able to produce 3.75 gigawatts of electrolyzers using domestic materials. That's a significant amount given that the world has just 11 gigawatts of manufacturing capacity in 2022, this according to the IEA. Evolo recently raised an oversubscribed $20 million Series A led by Engine Ventures with participation by 3M Ventures and NextEra Energy. Rojas said the company will use the funding to refine its manufacturing process, deploy some large-scale pilots, and sign paying customers. The company is positioning itself as something akin to TSMC, the contract semiconductor manufacturer that makes chips for tech companies around the world. It's a model that has worked out extraordinarily well for TSMC, though the company's success is due in part because the global semiconductor market is so large. Evolo's success is similarly dependent on just how large the market for hydrogen becomes. If it remains relatively small, the startup could find some limited success. But if hydrogen becomes a cornerstone of several industries, then Evolo's bet on manufacturing will pay off handsomely. Okay, so I came across this article and it made me realize something. Many of us that cover and discuss the hydrogen landscape focus primarily on economics, technology, or project development, and that's me included. But when I hosted the Hydrogen Summit with HBH, I began to understand much better the other industries that need to be included in the hydrogen conversation. Fabrication, grid integration, manufacturing. And Evolo is a prime example of that. Improvements in electrolyzer supply chain manufacturing, as well as domestic material sourcing, are great ways to drastically reduce production cost, which ultimately lowers both the project cost and the risk profile. Now, will the electrolyzer market jump to the point that Evolo is hoping it will? That's a big question. By now, you all know my thoughts on how the hydrogen market should evolve, and this company and its manufacturing mindset is a prime example of that. Use the easiest, cleanest, and cheapest form of hydrogen technology to establish the market, and then roll out electrolysis when price parity is reached. Now, I'm definitely going to be keeping an ear to the ground to see how Evolo grows, and I look forward to seeing their technology progress. Next, in an article in oilprice.com, Felicity Bradstock writes, Airbus, Rolls-Royce, and EasyJet team up for hydrogen-powered flight. Felicity writes, there has been increasing talk about the potential for hydrogen flight in recent years, as aviation companies look to decarbonize their operations. As passenger electric flight looks increasingly difficult to achieve due to the heavy weight of existing electric batteries, airlines are exploring the potential for powering planes using hydrogen. To achieve this, they will need the backing of governments worldwide, as well as significant public and private investment in research and development in the hydrogen and aviation industries. Aviation is categorized as a hard-to-abate industry, which still relies heavily on hydrocarbons. In 2022, the global aviation industry contributed to around 2% of the world's carbon emissions. This figure is expected to continue growing as the demand for air travel increases in the coming decades, unless an alternative green energy source can be scaled for mass use in the industry. Member states in the International Civil Aviation Organization have pledged to achieve net zero carbon emissions by 2050, meaning that they must invest heavily in research and development into alternative energy sources to power flight, including electric batteries, hydrogen, and sustainable aviation fuels. In September, 3 major aviation companies, Airbus, Rolls-Royce, and EasyJet, joined forces to launch the Hydrogen in Aviation, or HIA, to prepare infrastructure, policy, regulatory, and safety frameworks for when the first hydrogen-powered aircraft takes flight. Other HIA members include British parts maker GKN Aerospace and Denmark-based green energy company Ørsted. The group hopes that the government will work with it to develop the necessary regulations and standards required to safely achieve hydrogen flight in the next decade. The CEO of EasyJet, Johan Lundgren, stated of the alliance, "It would be unforgivable if actually the aircraft were available ready to fly and we could operate them, but actually it got held back because one of these policies weren't in place." This month, EasyJet joined other HIA members to urge the government to invest in hydrogen-powered flight. Lundgren has repeatedly highlighted the, quote, astonishing progress in hydrogen flight technology and believes there could be flights using the technology by the end of the 2030s. The HIA hopes that the UK will be at the forefront of hydrogen-powered aviation, but it will need support from the government to achieve this. The group published a report calling for public funding to support its aims of decarbonizing aviation using hydrogen, detailing the steps required to support this objective. It emphasizes the need for adequate sectoral regulations, infrastructure development, a skilled workforce, and the research and development of hydrogen aviation technology. The report provides the first comprehensive UK roadmap for the development of hydrogen-powered planes and could help the industry decarbonize in the coming decades. Lundgren stated, "The report is the first time we've had everyone across the board saying what's needed, from experts across the field, setting out actions by timeline before we can see hydrogen aircraft in the sky at a large scale. The breakthroughs in hydrogen-powered technology happening across the UK are truly astonishing, but these advances will be inconsequential if we fail to complement them with the appropriate skills, infrastructure, investment, and regulation needed." However, Lundgren believes the industry will require a staggering investment from public and private sources to achieve its goals. While the HIA is optimistic about the potential for hydrogen flight, it acknowledges that it has a multitude of technical challenges to overcome to achieve its aim. Hydrogen is still extremely difficult to store and transport. High levels of investment will be needed to develop the infrastructure required to produce, store, and transport hydrogen before it can be considered for use in aviation. Further, at present, only around 1% of the world's hydrogen is considered green, with most of it still being derived from hydrocarbons. Greater investment will be needed not only in hydrogen-powered flight, but in the expansion of the green hydrogen industry as a whole. This should not, however, deter the UK government from preparing the regulatory system and infrastructure required to support hydrogen flight. The aviation companies in the HIA are all optimistic that they will achieve hydrogen flight in the coming decades, with Airbus aiming to launch a 100-seat hydrogen-powered aircraft by 2035. EasyJet hopes to develop similar planes by 2040, and Rolls-Royce believes it can develop the hydrogen technology required to power small, mid-size aircraft from the mid-2030s onwards. With major aviation companies working together to achieve low-carbon flight, it could help the UK lead the way in hydrogen aviation technology over the next decade, providing the blueprint for others to follow. Okay, so this is very promising news that the aviation industry is collaborating to develop hydrogen policies and regulations for future air travel. Now, one point that was made earlier in this article is that the HIA is not just focusing on hydrogen, but also hydrogen derivatives like synthetic aviation fuel, or SAF. SAF is considered a low-carbon fuel when made from low CI hydrogen, and here in the US, that SAF is going to be highly sought after. Many of you know I attended the Low Carbon Fuel Standard bill signing in New Mexico and also had the opportunity to discuss hydrogen and SAF with Governor Lujan Grisham. She is extremely excited about both the bill signing and clean hydrogen development in the state. And as more states sign similar bills enacting LCFS, SAF and hydrogen derivatives demand will only continue to grow. All right, that's it for me, everyone. If you have a second, I would really appreciate it if you could leave a good review on whatever platform it is that you listen to. Apple Podcasts, Spotify, Google, YouTube, whatever it is. That would be a tremendous help to the show. And as always, if you ever have any feedback, you're welcome to email me directly at info@thehydrogenpodcast.com. So until next time, keep your eyes up and honor one another.
Hey, this is Paul. I hope you liked this podcast. If you did and want to hear more, I'd appreciate it if you would either subscribe to this channel on YouTube or connect with your favorite platform through my website at www.thehydrogenpodcast.com. Thanks for listening. I very much appreciate it. Have a great day.